Hello students, how are you? This is Irshad. I can help you to understand physics easily along with the numericals. In the last class, we have discussed about refraction, laws of refraction, when the ray of light travels from rarer to denser, denser to rarer, refractive index, the factors affecting the refractive index. This and all we have seen. Now we are going to see refraction through the rectangular glass slab, and second, how the factors affecting the lateral displacement that we are going to learn. See here how we can start to do this one. Let us take a rectangular glass slab, place on a whiteboard or drawing board. There is a white paper on a drawing board. Place a rectangular glass slab, use a pencil, draw the outer lines, then you will find a rectangular box. It has 4 vertices. The naming, let me remove the glass slab, give the naming A, B, C, D. So we know that this rectangular glass slab we place in the A. So A refractive index is 1 N1 and glass is N2. So first medium is a A, second medium N2 is a glass. We know very well the refractive index of glass is greater than the refractive index of A. I mean this is the rarer medium. A is a rarer medium. The glass is a denser medium. Denser medium. I mean there are 2 refractions take place through the rectangular glass slab. First, rarer to denser. Second, denser to rarer. 2 refractions. So first is AB is the first refracting surface. So it is the first refracting surface. And DC is the second refracting surface. Second refracting surface. For AB surface, I will draw the normal. Normal it is. Area, it is a N. Incident ray. And this is the incident angle I. Light ray travel from rarer medium to denser medium. As we learned that when a ray of light travels from rarer to denser, the refracted ray is bends towards the normal. So bends towards the normal and passes. Bends towards the normal. This is the refracted angle. Refracted ray. Draw the normal to the DC surface. Normal. These two are opposite angles. So R. This is also normal for DC surface. When a ray travels from denser to rarer, the refracted ray is bends away from the normal. Away from the normal. This is we can call emergent angle. This is emergent ray. So if I will write here, this is the incident ray. This is the emergent ray. Angle A is a emergent angle. Angle R is a refracted angle. Angle of refraction. Angle I is the angle of incidence. Angle of incidence. Now I will take a path of the right. Incident ray it is. I will extend the forward direction with uncontinuous line. So this is the path of the incident light ray. So I will write here path of incident ray. Path of incident ray. So once again here, radar to denser, the refracted ray is bends towards the normal. Denser to radar bends away from the normal. I is the angle of incidence, R is the angle of refraction, E is the angle of emergent. This represents the path of the incident light ray. So how both are appearing? Emergent ray, the path of the incident light ray, appears parallel to each other. So it is both are appearing parallel to each other. Then we can say here the perpendicular displacement between the path of the incident light ray with the emergent ray is called lateral displacement. I repeat, the path of the incident light ray, emergent ray are parallel to each other. The perpendicular displacement between emergent ray and the path of the incident light ray called lateral displacement. Lateral displacement. This lateral displacement depends on three factors. So how many factors? First factor is angle of incidence. Angle of incidence. Second factor, refractive index. Third factor, thickness of the glass slab. Thickness of glass slab. On three factors. So lateral displacement depends on three factors. The first one is the angle of incidence. The second one, angle of refraction. Third one, thickness of the glass slab. Then there is a question here: how the lateral displacement depend on angle of incidence, refractive index, and thickness of the glass slab. Then I will write here this lateral displacement is represented by x. Then x is directly proportional to angle of incidence. More angle of incidence, more lateral displacement. Lateral displacement is directly proportional to refractive index. More refractive index, more lateral displacement. Lateral displacement is directly proportional to thickness of the glass slab. More thickness, more lateral displacement. I mean, this lateral displacement depend angle of incidence, refractive index, thickness of the glass slab directly. So more, for example here, more angle, more refractive index, more thickness, more index. There is one more factor here. The refractive index is inversely proportional to wavelength of the light. The refractive index is inversely proportional to speed of the light. Then this lateral displacement is inversely proportional to wavelength of the light. Lateral displacement is inversely proportional to speed of the light. So this is the rectangular glass slab. So what we have done here, we have taken a rectangular glass slab, placed on a whiteboard, using a pencil or a pen. We have drawn the outer line. It has 4 vertices naming A, B, C, D. We remove the glass slab. AB is the first refracting surface, DC is the second refracting surface. The first refraction takes place rarer to denser. The second one is denser to rarer, bends away from the normal. The perpendicular displacement between emergent ray, the path of the incident light ray, called lateral displacement. The lateral displacement depends on three factors: the angle of incidence, angle of refraction, thickness of the glass slab. In the coming class, we are going to learn thin plane mirror and thick plane mirror. Thank you. Take care of you. Bye bye.